Example 8. A bicycle wheel with radius 14 inches has the bottommost point on the wheel marked. The wheel then begins rolling down the street. Write a formula for the height above the ground of the marked point after the bicycle has traveled X inches. Okay. Now, here's the trick to this question here. We are going to think about this right here as being our x-axis. And we'll think about this right here as being maybe our h-axis for height. Okay. And the next thing that we're going to think about is, well, right, our beginning height is 0 because we're starting at the bottom of the wheel. And then as the wheel starts to rotate, the question is, what's going to happen to the height? Whether we roll to the left or roll to the right, that height's going to go up. Okay, so we expect to maybe have something that might look like this. And the highest it can reach is the top of the wheel, right? And the lowest it can go is the bottom of the wheel. Okay. Gives us something that looks kind of like this. Okay, and you could imagine the center of this shape that we just put in here. Go right here. And this should just be whatever the radius of the wheel is. And this is helpful because now we know the distance from the middle of the wave to the bottom of the wave, or the middle to the top, either one, is 14 inches. So we could start actually writing our equation now. We have h equals, I'm going to write a 14. Now we need to think about whether we want to use sine or cosine here, right? If we're thinking about y equals sine of x, we normally think about it starting at the middle of the wave, at least speaking informally here. But cosine starts at the top of the wave. And if we just multiply cosine by -1, that'll reflect it across the x-axis, and it'll have the desired effect. We'll get something that looks like this. So we're going to go with -14 cosine, and then we'll have something times x here. Okay. To figure out what that something times x is going to be, we need to think about the period. Okay. So if we want to be able to figure out the period, what we really need to figure out is what distance is covered by the wheel when it does one complete revolution. Okay. And we can actually figure that out. Okay. Let's write a little something over here. Okay. So the bike would have to travel, I'll leave a blank here for a second, inches and I'm going to leave actually a little bit of space there too. For the marked point to make one revolution. Okay, so yeah, that's the key here. We want to know how far has this tire went in the time that it's made one revolution. Okay, and to figure that out, we just need to figure out what the circumference of the tire is, because if the tire does one full rotation, it's going to travel its circumference. Okay, so you might remember their circumference is 2 pi r. Okay, and r for us is 14. So this is 28 pi then, 28 pi inches. And I was just going to write in the parentheses here the circumference. Yeah, so the bike would have to travel 28 pi inches for the mark point to make 1 revolution. Okay. Now, we still actually have a little bit of algebra left to do that's going to come from this. Okay. So since we know that the period is 2 pi over b, and we know that 1 period is actually 28 pi inches, well, we can solve this for b. Okay. If we go ahead and solve for b, we should get b is equal to 1 over 14. So I'm going to go ahead and write that in here, 1 over 14. And this is times x. Okay. And we don't have a phase shift here. Okay. And there is a vertical shift though. So the center of our wave here is not along the x-axis, is it? It's 14 units up. So I'm going to also have to add 14 here. All right, example 9 is very similar to the one up above. I want you to pause the video and give this one a try. Now that we've given this a try, let's see how we've done. All right, so all I've sketched in here so far is the Ferris wheel and the platform that it's on. Okay, so the platform, we're told, is 2 meters. And we're also told that the Ferris wheel has a diameter of 135. So if we split that in half, we should get the radius. So that makes the radius 67.5 meters. Okay. Now let's try and figure out what trig function is going to describe a rider's height. Okay. And I'm going to go ahead and just note to myself that the center of whatever our trig function is, sine or cosine, the center of it should be right here. And right, the x-axis is down here. Oop, that's not what I wanted to do. There it is. Okay. And the other thing is, if we're getting on a Ferris wheel, right, we're going to board it at the bottom. Just like in the previous example, we expect from here that we're going to go up. Okay, because we were at the bottom of the Ferris wheel, we have no choice but to go up if we're on it. Okay. And the highest we should go is right the top of the Ferris wheel. And the lowest we should go is the bottom of the Ferris wheel. Which means we technically won't make it down to the x-axis. Okay, right? Because we have that 2-meter platform. All right, well, let's think about this now. Well, if the distance from the center of the wave to the top of the wave is just the radius, we know that A is 67.5. And now, if this down here is h equals 0, then the question is, well, what's this height here? Well, it's the platform plus the radius. So if we take the platform plus the radius, it gives us 69.5. Okay, so we have A and D here now. All we have left to do is find maybe B and C. Okay. And actually, we won't have a phase shift, so we're not going to have to worry about C. But in order to figure out B, we need to be able to figure out what the period is. So this says the one complete rotation every 30 minutes. Okay. So the period is 30 minutes. And remember, the formula for the period should be 2 pi over b. I'm just going to write a little note here. This is the period. And we could multiply by b and divide by 30, so we get b is equal to 2 pi over 30, or how about pi over 15? Now let's start trying to write down the equation. So we have y equals, or again, if we want to use h, we can use h. The amplitude was 67.5. And since we're starting at the bottom of the wave, just like in the example up above, we know we want to be working with minus cosine. B we found to be pi over 15. And we haven't chosen what we were going to use for our variable here, but why don't we just stick with t for time? There is no phase shift. And then we found d was 69.5. All right, and that's it for that one.